really bad for you. The survival rate is really low when you sit more than when you don't. And when they ask that question, they ask, do you sit all the time, some of the time, and so forth.
Here you go,
So here's the data. So you see, as people get older, I haven't learned how to tie my tie yet. This is delightful. As people whoops. Is there a pointer on this? A laser? Is there a laser? Oh, there we go. Okay, so this is the, as people get older, we tend to move less. And so this is the sitting that I just mentioned. So this was done with almost all the time down to almost none of the time. And they asked, and so here's what happens. The more you sit, the lower your survival rate. And this is sort of well known in the exercise science community. So this is a really important slide. And this one shows that when you go from, I don't know how to, sort of confused, there's so many monitors. So what this shows is that when you're in the lowest level of fitness, this is the couch potato, and you go to the next level of fitness. Can you see the arrow? Is it showing up? Yeah. Okay. So you go from level 1 to level 2. This is the biggest bang for your buck. And these are men and women at the Cooper Clinic back in 1989, and they have them walk on a treadmill to exhaustion, and that's how you determine if they're fit or not, and that's a valid way of measuring it. And so going from fitness level 2 to 3 to 4 to 5, you don't get the same bang for your buck as you do simply going from 1 to 2. So this is good news to tell your patients, right, that just getting off your duff, so to speak, stop being the couch potato, you're going to get more benefit than if you're going from a super-duper marathoner to a super-duper marathoner, right? Okay, so that's it for that stuff. So we'll talk about the science of this. So when you're thinking about exercise and on a more complex level, and we're designing programs, we think about it in terms of energy systems, and we think about it in terms of anaerobic exercise, so in glycolysis, more glycolytic activity, and this is greater than 85% of oxygen consumption maximum, and then aerobic exercise. Now, the thing is that any of these in the aerobic exercise group can be anaerobic as well if you do them hard enough, but we typically in our patients, we tend to go lower. And so 50 to 85% is the typical training zone for aerobic exercise and greater than 85% for anaerobic exercise. VO2 max is the volume of oxygen consumed, and so it's oxygen consumption. Thanks. Is that, need more detail on that? Need more than that? So, oh, okay. Okay, so it's the amount of oxygen consumed or transported out of the blood into the muscle. And so there's a whole cascade of respiratory enzymes that do this thing. And as individuals get more fit, you have higher levels of oxygen consumption, which I will talk about in another moment. But we tend to measure it in mLs per kg per minute. And so a very fit athlete could be the 80 or 90 range. 90 mLs per kg per minute, and for sedentary couch potatoes, the average American on a maximal test will go up to about 30. We're very deconditioned. The average really kind of fit person is about 55 or 60 mLs per kg. So Lance Armstrong and those guys are like 92 with resting heart rates of, 3. And, they... and even when they're exercising, like marathoners, elite marathoners, you guys ever go on a treadmill? Like, they go at 12 miles per hour for 2 hours and 10 minutes. Just stand next to your treadmill next time and watch it at 12. If it goes up to 12, most of them go to 10, right? Like this, right? 2 hours and 10 minutes. They have very high VO2 maxes, very high. And even low heart rates, even at those levels. Right, even at those levels. I mean, some of their heart rates can be 110 beats per minute. You may have had a patient who's got a resting heart rate close to that. So, and I'll explain those mechanisms in a few moments. So there's this thing with athletes, we want to be able to go back and forth between anaerobic and aerobic metabolism, so that if, let's say, you're doing an event, let's say you're biking and you come to a big hill, you want to be able to go back and forth between anaerobic and aerobic metabolism. Okay. If you have questions, then ask. I didn't prepare to just ask. Okay. And it's disturbed in obesity and diabetes, which may make these folks a little less fit, right? They're not able to go back and forth. They may get stuck in glycolysis. Glycolysis is where you're consuming mostly carbohydrate, high energy fuel, but it runs out very quickly, and you can't keep moving. You can't get back to oxidative phosphorylation and burning fat, and I will talk about that a little more too. So we talk about it. I like to sort of soften it up a little bit for people and just call it heart thumping exercise, and they kind of get that. And so I like to use the terms warm and slightly out of breath and out of breath and sweaty. So vigorous, going to the gym 3 times a week, working really hard, that's out of breath and sweaty. And more moderate, doing that accumulated of walking, that sort of thing, just get yourself a little warm and slightly out of breath. All right? So people can relate to that. So this is your ticker, and let me just bring these all in. These are all some of the benefits of aerobic activity and anaerobic, and that top one, the stroke volume. So when these guys' heart rates are only 110 beats per minute and they're running at 12 miles an hour, their stroke volume is extremely large, right? So you have heart rate and stroke volume for cardiac output, right? So either the heart's going high or the volume's going high, the volume per beat. And so when you get more fit, the respiratory enzyme pathways and the other transport mechanisms improve, and so you don't have to work as hard with the heart pumping. It's pumping a greater volume with each beat. All right? Any questions on that? This is a very important component of fitness, very, very important. When this is measured, this is sort of what you're looking for. You want an improvement in stroke volume, and then the rest of them, right? So you have greater diastolic filling time, so the heart can fill with more blood, so that when it pumps a greater volume, right? So longer ventricular ejection time, so you have more time to pump more blood. The heart is not in a rush, so to speak. It can pump greater volume when somebody's more fit. Okay? Okay, so when you design an aerobic exercise program, so aerobic meaning, so we're staying more in aerobic metabolism, so oxidative phosphorylation down in here, glycolysis up here. So we want to stay here. There are more calories in a gram of fat than there are in a gram of carbohydrate, so you need more oxygen to burn the fat. So if you're exercising and you're really out of breath, you're burning more carbohydrate, and if you're exercising not so hard, you're breathing a little more regularly, you're burning more fat. And this is good news to tell your patients who are deconditioned, because you can say to them, how many want to burn fat? And they all raise their hand. And then you can say, well, you don't have to exercise really hard. You can exercise somewhat hard and get a lot of oxygen in, because oxygen needs a lot of stuff. And I will tell them, I say, you know, you think about fat, it's like butter, and think about carbohydrate, it's like sugar. Which one takes more energy to get off your hand? And it's the fat, right? So it needs more oxygen to clean up. Okay, so it's really good news. Okay, so anyway, what you do, this is a 3.5 miles per hour, 1% elevation, just randomly picked one. 85% of the maximum would be over here, 160 and 140 at 65%. And I'll talk about those percentages in a few moments. So then what happens is you're doing this for some period of time. This is minutes over here on the x-axis. And then what ends up happening is that the heart rate at the same workload starts to decrease, right, because the stroke volume is increasing. So the heart doesn't have to pump as hard for the same workload. So you have greater stroke volume, right? So this is a really good indication of fitness. If you put somebody on the treadmill and they're doing the same amount of work, but now their heart doesn't pump as fast, you know they're more fit, more conditioned. Okay? And again, ask questions, because I don't know what you do or don't know. Ileana. Except for you, Ileana, you can't ask any questions. Yeah, exactly, because you'll have more oxygen delivery. So the preferred fuel is fat because it has more energy. The problem is that when you're unfit, you're going to be burning the fast fuel because it's really fast. I'm going to have a slide to show you that. But yes, as a percent of the calories expended, because you're going to burn the same number of calories whether you go 2 miles walking or running. If it's very intense exercise, you're still going to burn the same number of calories. It's just what percent is fat and which is carbohydrate. Okay, so this is what happens with fat utilization, Ileana. So this is pre in the dashed line, and carbohydrate up here, and then when you get more fit, it's the post up here. I'm sorry, so this is the post exercise, right? So it's moved up, more utilization, more calories. and then this is carbohydrate. So you want to spare carbohydrate when you're exercising. So here's the carbohydrate before, and here it is afterward. And this is really important because you only have about 1,200 calories or so stored as carbohydrate. And, glycogenolysis and glycogen, it doesn't keep up with the demand fast enough always. It does its best, but if you're sprinting at the end of a marathon or riding up a hill or running, you're going to run out of glucose pretty quickly because you're just, you just can't keep up with the demand for the oxygen, right? Okay? Okay, so this is sort of a standard result that you always get with exercise, that you have more fat utilization. Okay, so burning fat. So this doesn't work. Although the mechanism, no, excuse me. And none of these work. Exercise in a bottle doesn't work. And this doesn't work either. You rub it all over yourself and dissolves all your fat. But I have some if you want. Okay. So this is what I was talking about a moment ago. So this is exercise time in hours and % of energy expenditure. And so you're always starting out about here, and then as you do more exercise, your glycogen stores are used up, your blood glucose is used up, and free fatty acids start to go more. And so this kind of makes sense. And if you're fit, you're going to be able to do these long endurance sort of things. If you go to the marathon and you watch people 4 and 5 hours in, their BMIs get higher and higher, but they're still fit and they're still burning really a lot of fat, right? And that's what's getting them through the thing. Around 20 miles is when you hit the wall with the marathon, right? And that's where the glycogen is all depleted. So, you start breaking protein down and it hurts. I mean, it hurts, right? And your muscles seize up. It's like driving a car without oil. It's just, it's uncomfortable. Anybody ever hit the wall? Doesn't matter. Doesn't necessarily matter. Yeah. Your husband says he hallucinates when. Yeah, it's not unheard of, right? Yeah. He's the guy to stay married to, Ileana. And so there's this myth, right, that you're going to hear your patients, you don't burn fat. The guy at the gym told me you don't burn fat for 20 minutes, so I might as well not do anything because I'm exercising for only 15, right? So this defies biology, right? Because you're sitting here right now, you're burning fat. If I asked you to get up, the fat percentage would drop, but you would still be burning fat, right? You'd have to really sprint all out to get to that, right? Okay. So I get really excited about mitochondria, so I decided I would talk about it for a few moments. So here it is. You see it? I'm sorry, the mouse doesn't work so fast. Okay, so there it is. And so what I wanted to talk about was fat transport from capillaries into the mitochondria for a moment and the effects of exercise on this effect. So this was a paper that was published in 2000, Transcriptional Regulation of Gene Expression in Human Skeletal Muscle During Recovery from Exercise, and it deals mostly with fat transport. So there were 10 men physically active, and they measured the transcription during recovery from 60 to 90 minutes of exhaustive one-legged. So one leg is the control, and so that's very commonly done in exercise science studies. And it's 5 consecutive days. So only 5 days of exercise. So this is the pathway. I'm not going to explain it, except I want you to just focus on lipoprotein lipase and the carnitine palmitoyl transferase here. These are the only 2 I want to focus on right now. So this is the outer cytosol, and these factors help fat. LPL breaks down triglyceride, and carnitine palmitoyl transferase helps move the triglyceride across the mitochondrial membrane. So here's what happens. So this is really interesting. So this C is before exercise. This is 0 at the stop. And look at how quickly this is happening, right? So essentially, you're getting better the moment you exercise. I mean, this is like really happening. And it's, I say to the patients sometimes, if you understood the cellular molecular part of this the way I do, you would never not do this. You would always exercise because it's like so damn good for you, right? And it's changing instantaneously, right? And here's LPL as well. So it's like really good stuff. It's something we should be doing. So the thing is that as we get older, mitochondrial protein decreases. By the way, I should just tell you as well that this is the transcription rate, the expression, as well as messenger RNA. So it's working on a lot of levels. So, yeah.
Is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one, is there any specificity to this transcription? Is one
hold that question. I have a slide. I'm sorry. And it's many factors, to answer it quickly, simply. So we know that mitochondria decreases as we get older, and the thing is, can exercise help with that? And so this was a study with 7 obese men, 6 times a week, 4 to 6 sessions per week, and they were in their late 50s, 60s, and they went 30 to 40 minutes at 60 to 75% of that heart rate max. And here are some of these factors at the bottom here. And so what they found is that it's the inner membrane that's actually expressing at a higher rate. So this is really good news because you know that Christe is the opportunity for all that fat to get burned. And so the more you have, the better. So this is really good. You see an expression of number, absolute volume of the mitochondria as well, but the inside of it's getting really more robust. So this is really important. And again, this is happening really quickly. At this next slide, you'll see. So this is established sequence. And look here, you can see at the seconds. I mean, they're talking about seconds, minutes to hours, hours to day. I mean, you can see an increase of 40% mitochondria within 6 to 8 weeks. Yeah, it's very robust. So this is one of my favorite things here, is that exercise training increases mitochondrial biogenesis in the brain. And this is new data. This has not really been described before. This is in rats. This is really hot stuff because, number one, you know, there's this whole trend toward exercise and all of the emotional, mental kind of benefits and dementia and Alzheimer's and so forth. And so maybe this is partly that explains it. We also know that when kids exercise, they do better on tests immediately afterward than when kids don't exercise. So if you compare 2 groups of kids, the kids who exercise before the test score better. And I don't know for you, but I know that when I exercise, my head's just clearer, right? So there's a great increase in blood flow to the brain. There might be that feel-good phenomenon we used to describe 2 or 3 decades ago where the hypothalamus is kind of heating up. And, you know, with new technology, we can measure these things now. So, I mean, if you think that, I mean, what medicine does this, right? I mean, what increases the mitochondria in your brain pharmacotherapy-wise? I'm not aware of any, right? So, I mean, this is really, really powerful stuff. And, you know, you can tell your patients you'll get smarter. That's what I tell them, right? You'll get smarter. So, so here was the data from that for the I knew someone was going to ask me that. Yeah, yes, yeah, yes, yeah. Yes, yeah. Yeah, yes. Some of it is PCR. That's correct. That's correct. That's right. So these are the hormonal responses to exercise in terms of fat. So we have an increase in lipolysis. Lipolysis, for those who don't know, is the process where catecholamines like adrenaline, epinephrine stimulate the triglyceride inside the fat cell to break down into fatty acids so that they can leave, because the triglyceride itself too large a molecule to leave the adipocyte, so it needs to be broken. So you start exercising, heart rate goes up, you get adrenaline circulating around, and lipolysis is that process. So for the most part, all of these hormones increase lipolysis, and insulin does not. In fact, it stores fat, and I'll show you an interesting slide about that in a few moments. So everything sort of does the reverse of what insulin does. So when you lose muscle, and this is particularly so when you're losing weight, you decrease lipolysis and fat oxidation. So this is a study with 20 postmenopausal women for 6 months. They were on calorie deficit. They lost 12 to 20 pounds. And then there was an exercise group, and they did treadmill walking 3 times a week. They started with 20 minutes, 50 to 55% of heart rate max, and they increased it to 45 to 60 minutes. So here's what happens. So the decrease in lipolysis in the abdomen and the gluteal muscles, in the adipocytes in those regions, can decrease anywhere from 20 to 70% with weight loss of about 11%, and that's with no exercise. And then when they looked at the exercise group, the weight loss was 8% when they added exercise, and there was no change in this lipolysis. So the exercise preserves this. So this is really important, because if you want to burn fat and keep the metabolic rate high, when people lose weight, a lot of things change. There are a lot of compensatory mechanisms that try to defeat your weight loss. And so if we can reverse that reversal, then we're on to something. So it's really important for people who are losing weight. And I'll talk about that in a few moments. And then here's fat oxidation. So it decreased as well. And then when when exercise was added, there was no change. So in the gym, and maybe you'll get this question from people, do they do the cardio or the fat-burning workout on the treadmill? Anybody ever seen that thing, right? Yeah. So what ends up happening is that your patient comes to you and they say, I did the fat-burning workout, and it really didn't feel like I was working very hard, right? And the theory behind it is that when you're burning fat, in order to burn fat, you have to deliver more oxygen, so you work at a lower intensity. Right? So you've wasted your time because you spent 30 minutes at a lower intensity. You could have done more in the same amount of time, right? And so I did a quick little table here for you just to illustrate this. So this is two people, 150 pounds. They go 60 minutes. Their speed is 3 miles per hour and 4 miles per hour. The distance they go is 3 or 4 miles. And they're working at 60%, which is the fat-burning mode, because they're going at a lower heart rate so they can deliver more oxygen to burn more fat. And then the cardio one is a more vigorous 75%. So they burn 300 calories in the fat-burning one in 1 hour, and in here they burn 400. So they've already burned more calories overall. And the greater percent of fat, yes, they burned a higher percent of fat, but fewer calories. And really, when you do the math, sometimes what you find is even though the percent of fat was less, they actually burned more fat in the final analysis. So you can see that the fat calories were actually higher. So the bottom line is that you burn fewer calories and get less fit with fat-burning workouts, so you shouldn't do it. If you're going to spend your time exercising, we don't want people to exercise so hard they get hurt, obviously. But go ahead and put your time in. Go ahead and, make the intensity so that you're going to get fit. Okay. So why can't I spot reduce? So this is a question you'll frequently get. So this is the lipolysis, and here's where insulin is stopping the cascade from occurring, and these are where the catecholamines work. What I want to show you is that, pull this all in, is that insulin, the adipocytes in the abdominal region are very sensitive to catecholamines. So you have catecholamines stimulating lipolysis and breakdown. So the abdominal fat tends to go first, and the adipocytes in the lower extremities, in particular with women, are more sensitive to insulin. So if insulin is blocking the reaction, then you're going to keep those fat cells in the lower extremities more. So this could explain why it's very difficult for women in particular to lose a lot of excess fat in the lower extremities. Now, those... well, that depends. If you have insulin resistance, not necessarily. Right. Although most of the time, yes. And also keep in mind that that's a very transient, you're exercising for 30 minutes, the rest of the time, The insulin resistance does go away with the exercise immediately, and I'll show you that, but yeah. Okay, so this could explain a little bit why that's happening. This is, by the way, this is an image from our 3D scanner at our lab. This measures body fat with white light. It just bounces light off of you, and the light bounces back to these cameras, and you get these really kind of cool-looking images. We have people with body fat 60% in our program. We have the average BMI in our program is 43.1. We have people with BMIs as high as 80. So we have very, very large people. We have people with girth, circumference girth that's larger than their height. Not easily. Sometimes on carts. Yeah. So we're all familiar with metabolic syndrome, and it rises as we get older, right? And so so what you know is that there's this great effect that looks just like that. So what this shows is that fitness improves metabolic syndrome. So you get less of it, and at any age, right? So it's very protective. It's very, very protective. And it's also true for women, but you don't see anything, really? Look carefully. You don't see the bars. You see on the left, you see this red column right here. This is showing, and then this blue column is over here. You don't see that? Oscar, you're going to need to the ophthalmology department. I don't know what happened to it. I don't know. I don't know. It looks like a computer printout of some sort. I don't know what happened. But anyway, what we know is that what? No, I don't see it there either. Anyway, it's really simple. There's an inverse association. The more you exercise, the less metabolic syndrome you have. Shift your glasses a little bit. Okay. So, there's not even anything for women. So I don't know what happened there. So it doesn't work for women. It works very sporadically for men. Okay. So one of the, in the diabetes prevention program, for instance, there was, a prevention of diabetes. Are people familiar with the DPP? So they identified people who were at risk for diabetes, and it was a 3-year trial, an NIH trial. They spent about $800 million gazillion on this thing. And after 3 years, they stopped it because the results were so robust, right? So they reduced the risk of diabetes in these high-risk people by 58%, with 12 to 15 pounds of weight loss over a 3-year period, only about 7% of their body weight, right? And they walked 30 minutes a day, 5 days a week, and they got this really tremendous effect, which, by the way, was reproduced in Finland at exactly the same number, 58%. This is really rather extraordinary in terms of statistics, right? So anyway, one of the things that could be happening... Was there what? I don't recall. I don't remember. It's a good question. I don't remember. Oh, DPP? Oh, yeah. Diabetes. Yeah, it's a government study, so everything's available. Yeah. Absolutely. All you do is type in diabetes prevention program. There is a wealth. I mean, the thing was really like $600 million or something. I mean, we did it. We were one of the sites, and yeah, it's worth looking at if you're interested in that. So anyway, one of the things that might be happening, and I'll talk about visceral fat in a moment, but the other thing that's happening probably is when you have endothelial dysfunction, so the endothelial cells are these very active cells on the lining of the membrane, inner membrane of the cell, of the vessel, and so there's all these problems associated with endothelial dysfunction. And so what exercise does so nicely is that it creates this shear stress. So you start exercising, and blood is flowing at a higher rate, and it's sort of tickling these endothelial cells, and you get nitric oxide as a result. And the nitric oxide is a very potent vasodilator, keeps the vessel nice and compliant, and so that's probably one of the things that happened. They didn't measure that. But here's why it's really important, because when you exercise, well, when you're at rest, so the blue is rest, and then light exercise, moderate, and maximal, the heart gets about the same amount of blood all the time. But when you start to exercise, you get a redistribution of the blood flow from the gut to the muscles, right? This is why your grandmother always said don't exercise, don't swim after you exercise, right? Because you'll get a cramp. And what did I say? Sorry, yes. So his eyes and my ears. So look what happens. You're getting this enormous increase in redistribution of blood flow to the muscles, to the working muscles in particular. So this is very important, right? And even when it's not like heavy-duty exercise, so we're just talking light or moderate, right? Almost immediately. Yeah, almost immediately. I mean, this is partly also why sometimes you want to warm up so that you don't get like this drop in blood pressure and things. The cardiac output goes up, but it's probably... The coronary flow does, yeah, okay, yes. I think what it is, I guess we're talking here, I guess that there's no redistribution out of the cardiac. I don't know. I'm not really sure. You're right, though. You're right. So visceral fat. No, there's something. Well, that it is. That it is. The volume is not. Right. Right. Well, it's not a lot. It's not a large organ. Right. I'm going to think about that a little more for you, Oscar. I'm going to think about that a little more. Well, it's a percent for sure. It's a percent for sure. That is, yeah, it's not an absolute. It's a smaller organ. It's like the brain is a very highly metabolically active organ, but in terms of the larger picture, right? Okay, so visceral fat. So there's insulin resistance, diabetes, and so forth. Everybody knows all this stuff. So here's what's great about exercise and visceral fat. First of all, visceral fat is very sensitive to exercise. It's very lipolytic. You need a very little amount to get a really big bang for your buck. So let me show you. So this is 27 men. They exercise for 13 weeks, 45 to 60 minutes of walking or jogging 5 times a week, and no weight loss. So this is really important, no weight loss. And this is pre-exercise, and this is post, right? And so this is a MRI scan. This is the spine. The subcu fat is out here, so this is just visceral, so the organs and muscle, and the visceral fat is infiltrating the organs, and you see this tremendous reduction with no weight loss, right? No weight loss. So you might have a lot of fat burning. The compartment is small enough that when you reduce this visceral fat, you don't see necessarily a decrease in waist circumference, right? You just see a decrease in the metabolics, which I'll show you. So this is, you've seen these slides, I'm sure. So this is diabetes over on the right. And so this is an important paper. So these are 24 subjects. They're obese with type 2 diabetes. These were women. And they're cycling 45 minutes, approximately 3 times. They had a choice of 2 or 3 times a week for 8 weeks. And so here's what happens. The A1C before, everybody knows what the A1C is, right? Glycosylated hemoglobin, right? Okay, so the A1C drops from 8.5 to 6.2. Now, if you do diabetes, if you work in the field, you know that this is a tremendous drop. I mean, if you get half a point after 3 months, this is after 8 weeks. I mean, this is a really... Only insulin.
None of the oral medications do that.
No, but you know what else does it? Exercise. Yeah, only insulin, right. Yep, now watch. So here's what happens. So insulin sensitivity improves 46%, and the body weight changed hardly at all, right? I mean, it's really a robust finding. And the visceral fat decreased 49%. So it's interesting that the visceral fat decreased 49% and the insulin sensitivity increased 46%. They don't address that in the paper, but it's interesting. And the subcu fat only reduced 18%, right? This is 8 weeks. That's it. I wish they had done it. I wish they had. There is a dose response, and it's with exercise with all studies, so at some point it flattens out. I just don't know where. I don't know where. Yeah. This was biking. Biking. It was 45 minutes, 3 times a week. 2 or 3 times. They had a choice. I don't know how they kind of designed it that way, but it was 2 or 3 times. That's what they did. Right. As opposed to a bicycle. Bicycle much cheaper. A lot less side effects. Unless you fall on your bike. That's it'd be amazing how people fall off a stationary bike, but you're not going to hear me say negative things about exercise. And that city bike thing, anybody doing that? Nobody? Isn't that fantastic? You know the program where you rent a bike? They don't have a helmet. The guy on the river who has a bike rental thing, his business went 50% down after the first weekend. He's trying to get into the rent-a-helmet business, honestly. Yeah. Anyway, okay. So in terms of glucose transport, the reason I show you this slide, these pathways are very well described, but what I wanted to show you was that exercise seems to have its own pathway in some cases. Because, you know, like when you have people exercise and they stick their finger and they exercise, after they stick their finger, the blood sugar can drop, you know, like 100 points. And when you do in vitro experiments and you knock out insulin receptors, you still get decrease in blood glucose in vitro muscle, right? And so this is not well known yet, but there seems to be some, well, there's some exercise pathway, and maybe it's activated by calcium kinase, but it's not clear yet. But it's clear that, again, when you take muscle out of an animal or human and you put it in a dish and you stimulate it, the blood sugar drops without insulin receptor. So some effect. And, you know, when you have people exercise and they have diabetes and they have insulin resistance, like for that moment they're exercising, somehow the resistance goes away, right? So we're turning it over quickly. So just quickly, the GLUT4 is one of the transporters, the main transporter for getting glucose into the crossing the membrane and into the cell. And so what they show here, and this has been described many times, is that transcription of the GLUT4 gene is transiently activated after an acute bout of exercise, and GLUT4 protein can be increased as much as 2 to 3-fold after just a few days of repeated exercise bouts. So this was data from Della et al., and they do a lot of work in this area. And these were 7 men with diabetes, 8 healthy men, and they did biking for 9 weeks, 6 times a week for 30 minutes a session. And so you see these are the black columns are the trained, and so you see a greater, bless you, a greater increase in protein. So they did. They did. Yeah. It does, that's right. They did clamps with this. Most of these are, I don't remember specifically, but 60 to, what's that? No, above 60, above 60%. Yeah, somewhere in that range, right? Most of the studies are done like, if they want an effect, they push it a little bit harder. So then we'll talk about anaerobic exercise for a few moments. More glycolytic. You run out of breath very quickly. So this is weightlifting, sprinting, and these sorts of things. So there's this training method called interval training. People know it? Mm-hmm. Interval training. So this is a really well-known training method in athletes. And so what happens is you're exercising at your sort of regular rate of, let's say, 65, 70%. It's a pretty flat line. And then what you do is every few minutes, you increase the intensity. So if you're on the bike, you go up really hard for 1 minute, and then you recover, and this is called the active recovery, and then you go back up again, and back down, and back up, and back down, right? And as you get more fit, what ends up happening is that the heart rate is dropping at these higher workloads, and you can increase the intensity even more. You can do that, or you can decrease the interval, the active recovery part. So you could go 1 to 2.5 minutes, let's say. It just depends, because at some point it gets so hard to push that you just physically can't push any harder. So you might decrease. You play with the timing of the workout instead, one way or the other, right? The nomenclature is it's a 1-to-3 training ratio. That's how you start and work to active recovery, and then you can manipulate the time and so forth. So this is some data that we're doing at our lab, and I'm going to leave out the aerobic part and just look at the interval part. So this was 2 different, we were testing an actigraph and an EKG just to see how accurate the actigraph was, so that's why there are 4 lines. But what you see is that this is the beginning, and you see that this is the heart rate, and it's higher, and then at similar workloads over time, it's coming down, it's lower. And this is the case in all interval training studies. A very robust effect very quickly. And all athletes know this. If you want to increase your fitness, you go out, you start running wind sprints, and you get much fitter very quickly. right? We do this with our patients, though. They don't have to do up to 85% or so, but it gives them a little bit more oomph, and they notice the difference. So you can suggest that to them. So we're still working on that. So this was a study that was done. It's a nice study. I have just this one. This was sprint intervals. And so what they did was they had 16 active men, 6 cycle sessions over 14 days. They had 2 groups. The intervals were 30 seconds all out with recovery, and then 30 seconds all out for 27 minutes, and then they did endurance for 90 to 120 minutes. I don't know why they selected such a long endurance, but that's what they did. And so here were the results. So all these pathways, consuming more oxygen is increasing. Muscle glycogen, you're sparing it, which is helpful for endurance athletes who then need an extra boost at the end. Muscle is less acidic, so it's working better. And then at the end, they did a cycle. Well, they did a cycle trial at the beginning, at the end, and they improved a lot. The time in the time trial, so they went a certain distance, and they were able to do it much faster. So here's the thing about it. This was the most important part. The total training time was 10.5 hours for the endurance training group and 2.5 hours for the interval training groups. Sorry. So with less time. Now, the aerobic training, the endurance probably could have done less time. I don't think they needed to do 90 minutes. But we're finding in our experiment that even 15 minutes, even after just a few weeks, we're already seeing improvements. It just seems to be very effective. Okay, so metabolic rate during and after aerobic and resistance exercise. So I wanted to kind of dispel the myths about this a little bit, because it's always thought, right, and I think even when I was in graduate school, they taught us, well, metabolic rate stays elevated, you know, like for 6 weeks after you do a bout of exercise, right? And so here's the facts. Here's the results. So this is work that I'm doing in our metabolic chamber. So this is a woman with a BMI of 41.7, and so she's sitting in the metabolic chamber. The chamber is a room, it's about 8 by 10, and you shut the door, you seal it up, and it measures CO2 and oxygen, and you can get very accurately calorie expenditure, as well as what % of the calories are coming from fat and carbohydrate. So we use it quite a bit. So anyway, she exercises for 30 minutes on the treadmill at 87%, so she's working at the peak. So here it is, her metabolic rate. This is kilocalories per minute. It's rising, rising, rising. And then at the moment that it starts, the exercise stops. This was just at the end, this little extra bout, but it comes down. So within 30 to 40 minutes, it's almost back to baseline. So this happens in men, women, high BMI, low BMI. That's the way it goes. Same thing with resistance exercise. So you see a decrease of the metabolic rate. Now, when you hear that it worked, usually it's with young men who did like a 45 to 90 minute resistance exercise workout really hard, and it stayed elevated, you know, through to the next day, up at about 8% higher. But otherwise, it's not really what happens. It's not a reason not to exercise, but it's not what we thought. So I'm going to talk about resistance exercise. So that was me in high school. This is muscle before, after the workout. So you get breakdown of muscle tissue, and then the stem cells are stimulated, and this happens in minutes, right? So you have hepatocyte growth factor in minutes. So while you're doing it, you're getting this improvement, and then you get regenerated muscle. So it's important to know that it's not the fibers that are increasing, but the size of the fibers, the myofibrils themselves. And then there's this whole area of sedentary research. So people are really looking at what, we know that exercise is good for you. Now we want to know what's so bad about being sedentary. So this is an active muscle, a leg, and this is a sedentary leg of 47-year-old men, and so obviously we prefer this over here. So these are micrographs of soleus, the calf muscle, and this is before 17 days in outer space, and so that's one lipid droplet. And then what happens when you come back, these are Z lines, so they're fractured. And so the reason for this is that what? there's no gravity, right? So there's no pounding, so there's no resistance. And so this is a big deal in space science. And we've learned a lot from space science in terms of what to do. So this is before 12 weeks of inactivity on Earth. And so, and this is after 12 weeks of inactivity. So if you're living on Earth like you're in outer space, it's problematic. So you want to start moving again. So now the astronauts in outer space, what do? They exercise. And you can see that he's chained down to the treadmill so that he doesn't fly off the treadmill. So sarcopenia, so these are not actual, these I just shrunk the images, just took liberty to do that. But this is what kind of happens. But the reason that I show you this is that not everybody's going to get big muscles from weightlifting. And there's a central nervous system component to this. And this is really important when you're counseling people, right? And particularly elderly people or women who are not going to, you know, they're concerned they're going to get these big muscles, right? It's not really going to happen. And so what does happen is that when you start to look at the neurons, the motor neuron, you see a greater firing rate. So when you have anybody ever exercised and like got stronger after the first few weeks or even the first few sessions? Anybody notice that? Right? Why is that happening? Because the central nervous system is getting activated. So you're getting more muscle firing to the muscle right away. Right? So in the first few sessions, people are stronger, but there's no hypertrophy. Right? So these studies show that. So these are resistance-trained men and untrained age-matched controls. And so this is the discharge rate at the junction, at the motor junction. So you're seeing in the strength trained a much greater rate, right? And this is younger and older, and just bring these both in. And so what you see is in the older and the younger, you're seeing both an increase in the motor discharge rate right away. So they're getting stronger. It stays that way as long as they continue. Right. The detraining effect with weightlifting is you may maintain not maximal, but at least submaximal for at least 20 weeks. The detraining effect. If you stop, if you have somebody doing this for a while, and then you have them stop and detrain, 20 weeks later they'll still be stronger than they were at baseline. Once they start, if you take them back and give them an exercise test again, it's like they remember. The central nervous system remembers, and it's firing up those fibers again. Detraining. Yes.
Their strength will be the same?
No, it'll be less, but it won't. The maximal will, the submaximal will be close, but the maximal will be down. Right. Yeah.
But not so for aerobic.
Not for aerobic. No, aerobic goes away quickly, a couple weeks. Yeah, 1 to 2 weeks, and you'll see a big decrease. Right. Like all those mitochondrial changes, they sort of vanish to some degree. Yeah. The reason for that isn't well known. Exactly. Okay, so this was a study in 72 to 98-year-olds, and they had 100 subjects, and they went to a nursing home in Boston. The mean age was 87, and they did this for 10 weeks, 3 times a week, really hard, right? And they looked at muscle strength, walking speed, and so forth. And so here's what happens. The strength increases 113%. And the control 3%, the walking speed 11.8, and control down 1. The stair climbing 28%, climb stairs better, and the thigh muscle increased, right? So they didn't get big hypertrophy, but they got this enormous. So this is called the adaptive window in exercise science. When you start really weak, there's a lot of room for improvement, right? So they started the study, and this was the actual image that they used, the video, and this was after. See how they got a lot fitter very quickly, right? Okay, so the point there is it's never too late to start. That's my mom. No. Okay, so there's lots of different ways to do resistance exercise, and by definition, resistance exercise is any exercise that causes the muscles to contract against an external resistance. So it could be the tubes, it could be machines, it could be the dumbbells. And what I do with our folks, because our BMIs are really high, and it's a nice way to start them instead of walking because their knees hurt and they don't want to do this stuff so much. So what if they could do some resistance exercise? Sharon, hi, I didn't even see you there. So this is really a nice way to get them started, right? Because they don't want to walk in their knees and all that stuff. So, like here's the wall press exercise, and you just go like this. And what's the resistance? Your body weight. It's really simple, right? Your body weight. And so as it gets easier and they can do more than 15 repetitions, then you just have them go down lower to the counter in their home or wherever, right? So we take them through that progression. So we assign this to them very early in the program. And it's very helpful because they get stronger because they're not doing very much. So they feel stronger. Their back doesn't hurt as much and so forth, right? Okay. So when you're designing resistance exercise, you typically do all of this, by the way, is to volitional exertion. So you lift it until you can't do another repetition, right? But with good form. So it's 1 to 6 repetitions to emphasize strength only, 8 to 12 reps for strength and tone, and then 12 to 15 reps for tone, endurance, and strength. So I typically go with 12 to 15 reps to start with people because we don't want them to get injured and we want to find out if there's any kind of pre-existing something or other going on, right? But, this is something you could teach in the office, right? Imagine if you, as the healthcare professional, got up and said, here, do this exercise, right? They would be impressed, and maybe they would follow through. So for beginners, 1 set is enough. You have a question?
Can I just clarify something? The sets you're referring to are at 1 to 6 repetitions, you're at exhaustion.
At exhaustion at the last one.
So really, as you go down, you're actually getting easier.
Lighter. The weight is lighter.
The weight's lighter.
The weight is lighter, but you're still...
More effort to exhaust you.
More duration, longer. Right. That's right. But again, because you wouldn't want them lifting something really heavy, and let's say their shoulder had a rotator cuff before, and they don't do anything, so you can walk around for years with torn rotator cuff, but then the moment you give them something heavy, then they're not happy with you, right? They're mad, right? Okay, so 1 set for beginners is enough because of that central nervous system effect, and then 3 sets after 4 to 6 months when the strength level starts to plateau because it's volume, the amount that you're lifting, the total amount, so the weight times the number of repetitions and so forth.
Need to feel sore in order to...
That's a good question, yeah. In the beginning, they're almost always sore if they do it enough, but no, there's no evidence that you must be sore to get stronger, partly because of the central nervous system effect, right? In the beginning, they typically are. And if they're complaining, we tell them not to rest. A woman the other week, she says, well, she was so sore that she laid in bed for a week, right? And she stayed sore. Because why? Because she wasn't moving. So, the soreness is not really, the lactic acid, but that's only a few hours really after. It's typically because of the swelling. It's the swelling in the fibers. No, athletes don't. Athletes aren't sore after every workout. They don't need to be. And there's levels and how much people tolerate it, but no, they don't have to be, right? Fluid coming into the muscle to heal, protein, prostaglandins in the fibers. Right, exactly. And that's what it is, and that's why it's inflammatory, and that's why to help with the soreness, anti-inflammatories sometimes can be helpful, but movement is the best. Massage helps somewhat, but it's a little too mechanical, and you can't get the whole body. If you start moving, if your patients are complaining of soreness, tell them to move. That's best. That's best. The thing is, if they're getting so sore that they can't perform, then you need a break. But otherwise, to keep going, right? And so 2 to 3 days of rest in between workouts. Well, I don't know anybody who died from doing 2 days in a row of weightlifting, and you can ignore that. Just let them do it. Because, you're building behavior, right? And how do you build behavior? You got to behave. You got to do it, right? So you want to repeat that. And then, yeah.
I have heard from the physical medicine people at the hospital
Yeah.
that you can overdo this kind of medicine.
Yes.
And that in some patients, you'll go on a progressively decreasing curve if you try to train a fatigue.
That's right. That's right. So I instruct them that if they're finding that their soreness is continuing and, like I said, the performance is decreasing, or they go to the gym or they're burned out or they just can't do it, then yes, they absolutely need a rest. And on the other side of the coin is it's progressively overloading. So you pick a weight that you can do 12 to 15 times, and as that gets easier, you increase it, right? That was from Milo of Croton. Did that 2,000 years ago. He developed progressive overload. He wanted to marry the king's daughter, and the king would not permit him to do it because he didn't like Milo too much, but he gave permission to Milo to marry her if he walked 100 miles carrying a calf, an animal, right? And so what happened? He put the calf on the first day, and by the third day, the fifth, the 10th, the third week, what happened? The calf got heavier, you see? So this was progressive overload. It's true. Anyway, there you go. Yes?
A lot of these exercise videos and programs talk about muscle confusion, and so working one muscle one day and then the next day you do something aerobic, so you don't work that same muscle.
Yeah, I'm not very big on muscle confusion. I think that if your biceps are really sore, then give them a rest and do the triceps the next day and things like that. But there's, this idea too that, you should always change it up, and otherwise your fitness will, this is really, like marathoners, all they do is run, elite marathoners, right? And is their fitness getting worse? No, right? So you could, I pretty much do the same workout all the time, and most people tend to, and there's no decrement in my performance. So I don't think so. And as far as muscle confusion and just shaking it up, so to speak, well, what you're doing is you're just working different fibers and different muscle groups, and the biomechanics are different, so you're hitting more muscles. That's true. But I don't think muscles get confused. Yeah. What I tell them, Sharon, is I tell them to keep going until they get bored. Because if you give them variety, they're going to end up not doing anything because it's already overwhelming. So now you say, well, when you go to the gym and then the next day do this and do the elliptical on the next day and do the bike on the next and the treadmill. It's like food. The more variety, the more people eat. With exercise, it's the opposite. The more variety, the less they do, has been my experience. I say you do one thing, learn it, and then if you want to do something else. And you know what? Sometimes things are boring. And you do it anyway, right? Whatever. Listening to this is probably putting half of you to sleep, right? It's boring, but you got to do it, right? And that's just sort of how it is. So that's a cognitive behavior therapy disputation. Have you had CBT yet? I don't know. But anyway, this is what we say, right? Yes, I do. I like that too. No, I didn't say do something else. I said do something. Yeah, do the same thing. If what? Right. No, I'm saying do the bicep. I'm saying do it again. Yeah. But if it breaks down too much and you're not allowing any time for healing, then you're going to have that progressive down regulation. Yeah, soreness, right. Correct.
So the specific question would be, is there any data to say that re-exercising that muscle somehow advances the recovery?
Yes. Yeah, because when you study it and you look at anti-inflammatory medication and massage and all warm bath, nothing does as well, it seems. Anti-inflammatories work too, but movement is, and anecdotally, I'll tell you that it is. Yeah. Stretching, you can stretch too, but even static stretching is not going to do as much as the dynamic movement.
Again, I guess the question is, what moves truly
It's more movement. Exactly. That's right. So that woman who laid in bed for 7 days just remained the same amount of sore, right, until she came in and I whapped her on the head. You got to start moving again. But anything to not exercise, right? Anything to not exercise. Okay, so which abdominal exercise is the most effective in terms of firing the abdominal muscles the most? We don't have those clicker things you have at conferences. Anybody have a guess? Take a guess. Don't be shy. Which? Oh, the rectus, mostly. What's that? Did I circle? Let me see if I yeah, so that one is, right? Because you disable the hip flexors with 90-degree hip, and then this makes it harder than this because the lever arm is moving toward the fulcrum, so the weight is transferred here more, whereas this is further away. The fulcrum is your hip here because you're going up like that. So crunches are what every other abdominal exercise are measured against. So you put surface EMG, electrodes, or even needle, and when you have someone do a crunch, that's when you have the greatest activation of the rectus abdominis. So everything's measured against that. So anyway, there you are, right? Really simple.
That's why I have longer hair.
So you can do this in bed. You can tell people they can do it in bed. A little secret, though, is when you do these things in bed, they're harder because the bed sinks, and so you're actually working against that, and you've got to stabilize more. So floor is better, but don't tell it. Okay, so monitoring exercise intensity. So heart rate is one way to do it. In our population that I work with, heart rate is not a really good way because there's a lot of excess fat, and they can't feel their the vessel, so we don't use that. But I think what I'm going to do, these are posted, so I don't think I'm going to spend a lot of time on this, except to tell you that this is the heart rate reserve method. And you take 220 minus the age is the maximal heart rate, then maximum heart rate minus the resting heart rate is the reserve, then multiply the reserve times the percent training intensity desired, and then the value plus resting heart rate back is the training zone. So for example, if you're 50, the max is 170. This is age-predicted max is how we say it. It varies a little bit as you get older. It's a little bit off, and when you get much younger. So this works best in the 40s, when people are in their 40s. And then you subtract out the resting heart rate to 92, and then multiply the 92 by 55% training range, so you would get 51, and then add back the resting heart rate. So 129 would be 55% of the training intensity. The reason to do the heart rate reserve and not a straight percent is because the straight percent assumes then that the heart rate goes down to 0, which is always a problem if it's your patient, right? So that's why we do that. And this is just the standard, all right? And then if you wanted to pick another zone, you would just do the math for another one. So you can see why this is really hard for patients, right? Because you got to first teach them how to do it yourself, so it's complicated. They can wear heart rate monitors. And again, in our population, heart rate monitors don't work because there's so much excess chest fat that it bounces around too much. Yeah.
And also, it's important to remember that the maximal predicted heart rate is plus or minus about 10%.
As I said, with with older people and with younger, it's off. That's correct, right? But I've done a very complete analysis of that, and when you plug in all these numbers, it comes out to be not a lot of beats different, up to maybe 6 or 7 beats, which is not insignificant, but it's not what you think. I mean, you got to go up to like 100 years of age to really find like clinically significant or relevant changes. But yes, that's true. No, you could go to elite sprinters. They may train at 110%. Above 85%. Correct. Above 85%. That's what we sort of classically think about it as, right? But somebody exercising at a lower percent may be more anaerobic because they're deconditioned, right? So if I get somebody walking at 65%, let's just say if we can do that, they may be burning a lot of carbohydrate and less. Yeah. Okay, so this is an easier method. It's the Borg scale of perceived exertion, and it's just an visual analog scale from 6 to 20, and the work should feel somewhat hard. So you ask simply this question: how hard does the work feel overall? Not how much leg discomfort or breathing discomfort, but overall. And most people can use this effectively. So it's real simple, and you can have a copy of this in your office and use that. So somewhat hard to hard is enough.
What about the cardiac rehab method, which is where you teach the patients if you can sing, you're not working hard?
Yeah, so there's the sing test. I don't know anybody who sings when they exercise a lot, but yeah, there's a test actually to measure respiratory distress, and you sing the national anthem, or I'm sorry, you say the Pledge of Allegiance, and you can determine there. So yes, I'm not opposed to it. I just don't know.
Just
Sing. That's right.
No, you should be able to sing.
To speak.
If you sing, you're not working hard enough.
Yes. Yes.
And speak, then you're at the right
Yes.
level. And if you
Yes.
can't speak, it's too hard.
Yes.
So that's probably okay.
In general, that's correct.
For
Here's the thing about that. One of the problems with it is that you get out of breath pretty quickly when you start talking in your exercise, because it throws off your breathing rhythm immediately. And so that's where the problems start to come in. You know, she told me to start singing and talking, but, you know, now I'm not breathing the same way I was when I was exercising, and so now I'm getting out of breath really fast. So that's why I don't use that so much. Plus, they may look kind of funny singing to themselves, but I don't know. Oh, sorry. Okay, so recovery heart rate is withdrawal of the sympathetic nervous system and reactivation of the parasympathetic. So what happens is when you start exercising, you get an increase in sympathetic, adrenaline and so forth. Heart rate will go up, and suppression of vagal activity to allow the heart rate to go up. And then in recovery, you get an increase in vagal activity again and decrease in sympathetic. By the way, this does not work so well in obese individuals. It's actually suppressed. I'm starting to write a grant for this right now, where obese individuals have a suppression of vagal activity and an increase in sympathetic, and heart rates are going really high. I've seen patients who are obese exercising at 100% of their maximum for like 5 minutes without, I'm just talking, pretty much. So anyway, the reason I'm showing you this is that there's a lot of evidence that recovery heart rate is a really good predictor of mortality or premature mortality. So in these studies, they show that an abnormal value for the recovery of heart rate was defined as a reduction of 12 beats per minute or less from the heart rate at peak exercise. So you have somebody exercise and their heart rate doesn't drop 12 beats from the peak within a minute, it predicts mortality. Yeah. Within a minute. Yeah. 1 minute. 1 minute. 1 minute. And, you know, there's sort of historical precedent to that. If you were a hunter-gatherer, you needed to recover really fast, right? Because otherwise, you blood pressure comes back extremely quickly. Yeah. Right. They don't talk about blood pressure per se in these data, but yeah, I would imagine that's part of the mechanism here. Yeah.
Can I just ask how you define peak exercise?
The heart rate. No, whatever the maximal heart rate was. So if you got a heart rate up to 160 and it goes down to only 150 within that first minute, then there's some risk. And by the way, also, this is a nice way for people to monitor their fitness level in the field. So if you can ask them, well, how quickly are you catching your breath after you've walked down the street, right, or climbed a flight of stairs? If they're recovering fast, it indicates that their fitness level has improved quite a bit. I believe that heart rate recovery is the best indication of someone's fitness.
I think this is symptom-limited.
Yes, stress test.
So this is exercising as much as that patient
Yes.
person can do.
Yeah.
Maxing yourself out.
Maxing yourself out, or even submaximal to some degree.
When I bike and my aim is to get my heart rate at 85%,
Yes.
stay for 45 minutes.
Yeah.
And you said when I stop, I should be down.
If it's not maximal, you should be down beyond the 12 for sure.
That's not maximal.
That's right. That's right.
And
Go ahead.
for elite athletes or trained athletes, are you looking at the delta from the max to their nadir or
To determine their fitness?
yeah, and is it at
It's not, it's not.
is it at 30 seconds?
Right. It's not the standard thing that exercise scientists look at to determine fitness level. It's more just the peak VO2 than the recovery. So, yeah, there's not a lot of data for that, but it definitely does. I mean, they never lose their vagal activity. I mean, that's why they're exercising. Their heart rates are 110, 120, 130. So that's part of the function of it, the cardiac stuff as well.
Those elite athletes, would you see them drop down to
Quickly.
50%?
Fast. Yes. Very quickly. Very quickly. Yep.
And they'll all go down pretty much the same.
If they're fit and elite, yeah. Yeah, the exact number I can't tell you. Sure. Yeah. Well, with these, they just stop them and lie them down. Yeah, yeah. You know, you don't want them to get vasovagal, so you lay them down. But this is not something I recommend doing. You know, they get orthostatic really fast. Stopping on the treadmill after vigorous is not a good idea. Yeah. Yeah. So, yeah. But that's what they did here. Okay. So obesity and exercise. I think I'll go through this quickly. So essentially, basal metabolic rate doesn't change much with exercise. Thermogenesis doesn't change virtually at all. It's this that you have the most impact on volitional and non-volitional. So whether you're deciding to exercise or you're just fidget a lot, at the end of the day, it is the total calories that count, right? It's energy in, energy out, and that's the bottom line to weight loss. So this is what we talk about a lot. Plus, the metabolic rate may drop as they lose muscle, so we got to really increase this. You know, that's the thing about weight loss, right? When you lose weight, you weigh less, and so you have to either reduce your calorie intake or increase the exercise to accommodate for that. Because if you weigh 200 pounds and you walk a mile, you burn fewer calories than if you weigh 150 pounds. So you've got to accommodate somewhere. Yeah, more. Sorry, right. Sorry. Okay, so what we know is that obese people sit more. So here they're sitting more, and here they're walking less. This is a problem, right? It's a problem. Now, they do burn a lot of calories when they are walking, right? But they typically don't walk enough to equal the lean people. So this was a study where they wore a portable calorimeter to measure calorie expended during exercise. And so they had people wash dishes by hand or in the machine, wash clothing in the machine or by hand, you know, down by the river like they used to, walking the stairs. And then they had, where they could, they had people walk or bike to work compared to commuting. So the differences are not, you know, they're small differences, but when they added it all up, and they determined that they burned 111 calories extra per day when they did the manual stuff. So we always talk to our patients about this, that it equals 11.5 pounds in a year, right, if you do the math. So all things are never equal, but it's a point you can make. Whether it would actually work in the real world, I don't know. But it definitely does matter at the end of the day how many calories people are burning. So all of this little kind of stuff that seems trivial may not be so trivial, right? And any activity is better than none. So this is what we talk about. So this is you guys. So this is the hours per week you spend on the TV and computer. So either you're not telling the truth or you're doing really, really well, because these are good numbers, right? This is not what we usually see, right? That so little television. You're too busy. You're too busy. Theirs is good, right? You watch TV, right. Well, I did ask that question in a careful way, but even this is low. But anyway, there you go. That's what you guys did. You lose very little weight with exercise, and this will ultimately happen. The patient will come to you, say, I exercise 5 days a week and I didn't lose any weight, right? Oh, anybody ever heard that, right? You know, happens all the time. So here's a meta-analysis, and the numbers of studies are in the parentheses. So this is diet alone, and now these are averages on across many, many studies. So obviously there's a large variability, but this is the average, 10.5 kilos, and then when you add exercise to it, you lose only a little bit more. Well, all different. It's just a huge meta-analysis, right? And then diet and exercise, and then exercise alone. So if I divide the room in half and I say, you guys reduce your calories and you guys exercise, you guys are going to lose a lot more weight. So this is really important because you have people who want to lose weight and they're doing their exercise and all, and they get very discouraged very quickly. So you need to reassure them that it's going to help them in the long run because it's the single best predictor of keeping your weight off. So you're building the behavior. That's what you're doing here. That's what you're doing. So these are data from the Weight Control Registry. You all know the Weight Control Registry, right? So this is a study, a long-term trial, not even a trial, it's a registry of people who have lost more than 30 pounds and kept it off for more than a year, and this is documented by their physician or some other source. And they will fill out questionnaires over the people who are running it send them questionnaires, and they find out what they're doing, right? And so at this point, in about 10 years, the average, they've lost up to 66 pounds people have kept off. So people do lose weight and keep it off, contrary to what everybody says, 95% of the people. You know that fact, 95% of the people regain weight. You know where that comes from? One study in 1958 where Al Stunker did this study, and he had people lose weight, and then they withdrew the treatment, and the people regained their weight. And that's where it comes from. That one study screwed up everything, right? So nobody believes you can lose weight and keep it off. We have plenty of people in our program who lose weight. 2/3 of them, 8 years out, either keep their weight off or lose more. Because they burn more calories than they consume. Whether they eat less or burn more through exercise, whatever it is, at the end of the day, no matter what, you got to burn more calories than you consume. So if you have a patient who weighs 300 pounds and they're coming in and they tell you they're eating 1,200 calories and they swear on their mother, well, God help their mother, because it's not true. They're just not. And they're not intentionally necessarily. It's really hard to count calorie intake, right? Dietitians, studies with dietitians even, they just don't do it very accurately. It's really hard to do. So that's the thing. That's the thing. Oops, so sorry. So 92% of them exercise regularly. Most of them walk, and only 34% of the regainers exercise regularly. So why don't you lose weight with exercise? So this is why. This is one of the reasons. So it would take 45 minutes to burn 500 calories on the treadmill and about 5 minutes to consume 500 calories. So this is a problem. People get tired from working out, and so they rest more. And so this is like this paradox, right? You get somebody to exercise, they work out, and then they're really tired, so they go take a nap. And at the end of the day, they've burned fewer calories. And this is particularly true in elderly. It is. It's been done. Sure. So this is problematic. They figure they can eat more because they overestimate how many calories exercise actually burns, right? And they underestimate how many calories. They think this big, low-fat muffin has 30 calories, right? Does exercise increase appetite? Not for everybody. For some it does, for some it doesn't. The data is really kind of equivocal on it. If somebody's reporting to you, though, that they're hungry after exercise, number one, check when they ate last. Because if it's been like more than 4 or 5 hours, they're probably going to be hungry, just biologically hungry, right? If they exercise in the morning after a 10-hour fast, they're going to be starving. I mean, these are things, right? There's no evidence that they are. They can eat more, but there's no evidence that they are. No. The nutrient content, if they had lemon ices, half an hour before exercise, it's going to change their blood sugar, and so it's not going to, there's no satiety, so they're going to be hungry. Some people eat when they're thirsty, so you want to check that, and then the intensity of the exercise. Sometimes high intensity does it, and sometimes not, so you just want to ask. Up to 37% of the lost weight can be from fat-free mass, and exercising during weight loss preserves it. So we're running short on time, and I want to... This was a study we did at our lab, and people who dieted only to lose weight lost 28% of their weight from fat-free mass. When they added aerobic exercise, only 20%, and when they did weightlifting, they reduced their they only lost 8%. So this is really important, right? Metabolic rate didn't change very much, but the muscle mass was preserved. So there's this myth, you're not supposed to weightlift while you're losing weight. Wait till you lose all the weight. That's really bad advice. Bad advice. Oh, that's not showing up. Well, what it shows is that fat oxidation does increase after exercise, after resistance exercise. So let me get this one real fast. So what this found was that in aerobic exercise group, and these were in obese females with type 2 diabetes, their visceral fat decreased 4% and thigh muscle 1.3%. And when they added weightlifting, visceral fat decreased 10% and thigh increased 6.5%. But look at this. So these are really profound changes from activating that muscle fiber. And it's just a really easy way. I mean, you can do resistance exercise sitting down. So if you're working with obese folks, this is really pretty simple. Okay.
That's one of the most important things to emphasize. They weren't changes necessarily
Yeah, correct. Right. You know, when you have older folks in particular more concerned with their health, and, you know, I mean, you know who loses the most weight in our program? Women in their 50s. They lose the most weight. People in their 20s lose the least amount. It's like a U-shaped curve. At the nadir is the women. Women in their 50s. Probably because when I screen them, they talk about it's time to take care of themselves, like maybe their children are out of the home and so forth. They're more mature. 27-year-olds want to go out and drink with their friends and so forth. But anyway, that's how it looks. Women. So why did I say that?
What I was trying to emphasize is sometimes we focus on
Oh, health.
cost, but we focus more
The health. That's why I said, right. Yeah. So health for, yes, agreed. It's just talking to a 25-year-old about their risk of cardiovascular disease is not going to be so helpful. Might be, but yes, I put my money on that too. So we'll go through this fast. So is it effective? Yeah, it's effective. But all those data show that. Those are just some of them. There's dozens, right, that you can increase physical activity in people. So here are you guys. How successful do you think you are at helping patients change their, where's the mouse? Change their exercise habits. So 14% of you said you were successful at it, 71.4% somewhat successful, and 14.3% not successful. So I want to know how you're measuring it. How are you measuring your success with this? When you were asked this question, what were you thinking about? How do you know? What? Follow-up. Good. Right, follow-up, which I'm going to talk about in a few moments. So you follow up. Yeah, you ask. And you chart it? Sometimes? Yeah, good. Okay, good. So here's the most important thing. And I usually put this at the end, but I decided to put it first. This is what you're looking for. You're looking for self-efficacy in your patients. You're looking for them, the belief that they can do this. Not only can they do it, but that they'll be doing it in 6 months from now. And the way you determine that is ask them, will you be doing this 6 months from now? If they say yes, then the probability is higher that they will be than if they say, I'm not sure. You can do all these fancy tests to determine behavior change. Just asking really helps. So anyway, the point is that when you're counseling them, you want to meet with them where they are and what is it that they can do and set goals that are realistic so that when they come back the next time, they said, I did it, right? Because if they continuously fail, their self-efficacy is really going to be low. So this is really important. I can. What is it that you can help them do so that they believe they can do this thing and that they will continue to do it? So with that in mind, 48% of patients report that their physician doesn't ask them about it, and this has been confirmed a number of different times. So I asked you what percent you counsel about exercise. So, clearing my throat because 33 and 38% of you don't counsel about aerobic or resistance exercise. The numbers here are the numbers of responses, right? So, does anybody have any comments on that? I thought this was important. You're all just looking at me. You might reflect your practice, and I'm going to talk about the reasons why in a moment. Okay, we'll move on then. Okay, so your barriers to counseling about aerobic exercise. So here you are. So I don't know if you can see it on the x-axis. I have no barriers. Let me put the percentages in. 28.6% said I have no barriers. 38% said not enough time, and this is the most common barrier, right? By far. When you ask anybody about this, they'll always say no time is the number one. And we'll talk about no time in just a moment. Luckily, nobody said they don't believe it offers any benefit. 19% said not enough training, knowledge, or experience, which is instructive. Little or no reimbursement, which we can understand. Nobody said they were uncomfortable with exercise counseling, and then 33% said other, and these were some of the others. When they don't show an interest in making any change, patient limitations, chronic illness, cardiac conditions. Sometimes the patient is not ready and you have to wait to encourage it. I start small and add on. So whoever said that is on the money as far as I'm concerned. You don't want to give up, right? And you had stages of change, I guess, earlier today, maybe. So I think everybody's at a stage of change where we can do something, right? That we can do something. I mean, if you think about what I've shown you today, if they can even just walk around the block before they go home, it's an intentional change in their behavior. So, I think that if somebody just simply doesn't want to, I don't think that's enough. I don't think we ought to give up, that we can find one thing that they can do. Either they suggest, you suggest it, or you ask them, just scan spend 2 minutes with them. How do you get to where, is there anywhere in your life where you could move for 2 minutes, right? Because what's the hardest part? Getting started, right? So there's the greatest benefit, is getting somebody to make the change, the intentional change, right? I mean, walk around the city. Watch people waiting for buses on a day like today. I mean, really. And a bus that's going to take them 4 blocks, 6 blocks, 8 blocks. The crosstown bus at Lex and 86 is filled in the morning on beautiful mornings heading east. How many blocks are left, right? I come across from Central Park West, and I see people waiting at the park on these beautiful days, and there's like, 50 people waiting for that articulated bus, and it's a half a mile across the park, right? And they're going to wait there for 15, 20 minutes, and, that bus pulls up, and how long does it take for that bus to unload all of the people and then load them? It's unbelievable, really. You could be there in 6 minutes across. So if we start to make some intentional changes in the people who are resistant, right, for the others, you can do whatever you like with them, right? So I think that's important. Again, no time for counseling about resistance exercise. The thing is, there's not enough training and knowledge. I mean, really, here, there. Now you have more knowledge than you did when you started. Teach them that. I'm telling you, they do that. They do that. You can even teach them that on a sick visit, right? They have a sore throat. Because I know, not in another world. They're coming to you when they're sick. You're not necessarily going to have a lot of time to counsel. But what if you do this, right? I have more to say. Okay. So who said this, less benefit than cardio? I dare you to raise your hand. No. I find patients are more resistant than doing aerobic exercise, which is interesting because I don't find that to be the case necessarily, particularly when you teach them how they can do something really fast and easy. Like, what if you had those exercise tubes in your office? Say, yeah, right, just this is what you do. Have them do it while you're talking to them, or you do it while you're talking to them, or both of you do it. Right? So positive role models make good exercise counselors, and there's plenty of evidence for this, right? And these are bad role models. The good Lord gave us a finite number of heartbeats, and I'll be damned if I'm going to use up mine running up and down a street. And, he obviously tired from walking on the moon. So this was a large survey of personal exercise habits and counseling practices of PCPs, and so here were the conclusions. Physicians who exercise aerobically are more likely to counsel about exercise. So 73% of them were exercising aerobically. That's impressive. And physicians who perform strength training are more likely to counsel about strength training. Also not so bad, although we'd like the number higher, right? And inadequate time and knowledge are the 2 most frequent barriers. So that's what they showed, right? So here's what you guys showed. So here's the literature on what I just showed you. So these are the number of times per week you exercise. Aerobic is in this purpley color and the red is here. So the important ones to me are that 38% of you do at least 3 or more. And let me pull this in. Here we go. So in terms of aerobic, 66.7% of you said that you exercise 3 or more times per week, and 81% of you said you do 2 or more times per week. So I'm on board with 2 times a week of resistance exercise because it works, and it works fast, and you don't need a lot to get a nice response. So knock yourselves out. 2 times sounds good to me. So that's a large number. Is this true? Are you all really doing that? What do you do? You do yoga, okay. And yoga does count, right? Because there's studies to show that you do yoga, you do weightlifting, you get a similar effect. Other people? What do you do for resistance exercise? And that's a large number, 80%.
I work out with a trainer.
You do, okay.
Sort of basic calisthenics.
So the trainer, good, right? What else? Who does it on their own? Body pump, right? DVD and that sort of thing. Yeah, it's fun, right? It's good. Anybody else? All right. Let's move on. What? Sharon, Sharon, you're over here. I think everybody gets an added credit extra for this. Yeah, well, it's. So I think every time you see her, you ought to ask her how many wall presses she did and encourage her to start doing them as a role model. Okay, let me go quickly. So anyway, I was interested to know, is it really true that, is there the correlation that the more you exercise, the more likely you are to counsel? Well, I didn't find any correlation. So there's some publication bias. They're only allowing the studies that work to be published, because this doesn't clearly always work. It didn't work in you guys, and it didn't work for a resistance exercise either. It doesn't seem to matter. You can exercise, you can counsel even if you're not exercising. So there's instructive information. Do I have like 3 more minutes? Yeah? Okay. So this was a literature review on PCP counseling, who has and who should be counseling. And so the literature suggests that a physician-only approach is not the ideal intervention. We propose an interdisciplinary model and referrals to an allied health professional, right? So who do you refer patients to for exercise counseling? So 10 of you said, 47% of you said you don't refer. 28% said you refer to a fitness trainer, 19% to a physical therapist, and 14% to exercise physiologist. Some of you refer to a physician or physician assistant, okay, or dietitian. So how many of you are referring? Or here's what I suggest. You make contact with some fitness trainer, right, and interview them and make sure they're the quality person you want, right? And for those who can afford it, you'll refer them for fitness training. And there isn't a fitness trainer on the planet who doesn't want to have a relationship with a doctor or other healthcare professional. This is really puts a feather in their cap, right? So what if you interview them, start referring people, and ask for a monthly report? And then you put it in the chart, and then when the patient comes in, you ask the patient, how's it going, right? And this might be helpful. Yes? You do that. Okay. Right. Well, but you don't have a relationship with them. You haven't met them. You have met them? Well, they still don't know you. I would say make an appointment and go see them, right? Yeah, I would say. Yeah. So anyway, and you know, the other thing too is that you could, for those who cannot necessarily afford it, I am telling you as well, the fitness trainer will be happy to come to your office and do like a little group thing for patients, right? Maybe they pay $10 or something, and the fitness trainer will be happy to do it. So if you're creative, you could find it. Because frankly, I mean, referrals would probably be helpful. You refer out for everything else, so for things that you can't control. So why not this, right? If we're really, because, you know, how far along are you going to go in your exercise counseling in your practice? You know, I don't know the answer to that, but it's just something to think about. So the position statement from the American College of Preventive Medicine was providers should obtain training in behavioral counseling, use of a variety of healthcare team members, and look at this, effective interventions can be as short as 2 to 4 minutes. And this is really true. Like you read the literature and you say, oh my God, they increased their activity level with the doctor telling them to do just a couple of minutes. So I asked you guys, how much time do you devote? And look, 26.7% of you said you do less than, oh, I'm sorry, not times, it should be time, less than 2, the time, not times per week. So here you are, 1 to 2 minutes and less than 1 minute. How much time you devote to counseling? Yeah, I'm sorry, I did it wrong there. It's 2 minutes. 2 minutes, not times, right? Yeah, so you are doing something. I mean, what are you saying? What are you asking in that brief period? What do you say? I mean, a lot of you responded. I mean, 53% of you said you're doing 2 minutes or less.
I have an elderly population, and I teach them exercise to get out of a chair.
Yeah, good.
Some balance exercise.
Great.
And lateral raises with suitcase or something.
Fantastic. Great. Uh-huh. Yeah. It takes just a couple moments, right? Any questions? Okay, so I have a question mark after this because I don't know if you're always going to be able to just prescribe exercise and they're going to do it, right? Because it's not a sore throat and you're just prescribing an antibiotic. It's more of a collaboration, I think. Although sometimes I do believe that you just got to tell them to do it. And you got to have their trust, and, you know, be able to push them a little bit. If you're going to prescribe, here's something really simple. It's a simple walking plan. 5 minutes out, 5 minutes back. So just like it sounds, you suggest to them, walk out for 5 minutes from your door, turn around and come back. They got 10 minutes, right? You can increase it to 7.5, 7.5 back, and call it a workout. And everybody's happy. It's that simple. It doesn't have to be more complicated than that. If you want to prescribe anything, do that. 5 minutes out, 5 minutes back. Some other tips. Increase the endurance first, then the intensity. People will ask you, should I do it harder first? No, go longer first. So build up to the time you want to do it, 15, 20, 30 minutes, whatever it is you're going to do, right? And then the intensity. Because you don't want them to get hurt, and you want them to be out there. Any aerobic activity counts. Chair videos I have there, and that can be very helpful. Alternatives to the heart rate and RPE, just ask them to warm and slightly out of breath and sweaty, or feel your heart thumping. And so those are things I like to use. So we're almost finished. So this says, any history of physical activity in your family? So I say to start the conversation, this is what I recommend you do. You can just ask, but I suggest that you have them fill out a little brief physical activity questionnaire while they're waiting for you, right? And that way they know you're interested. Then you have something quantifiable, and then you can, you know, have more structure to the interview that you're going to do with them. Because you can just simply ask, do you take the bus all the time? You know, you can ask those questions. You can put anything on that questionnaire you want. And then you can document that and put it in the chart. I think goal setting is important, but not for everybody. Not everybody will respond. So I think that they should fill them out each week at home. See, be as specific as possible. Because if it's not specific, then they're probably not going to end up doing it, right? Beware of all or nothing thinking. What does the all or nothing thinker do? They say, I'll do 7 days, right? And then they do 6. And then they see it as failure. What if they had said 5 and they do 6? They see it as success, right? So all or nothing thinkers are notorious. It's insidious, and so we want to be really careful with that. I like gold stars. We still use them with our folks, and they still like them and respond, and it's kind of fun. You know, you can get a pedicure, you can get a massage, all sorts of things. We kind of stay away from food rewards, but we're running a weight loss program with people who are very heavy. But, you know, that's up to you to decide. And tell patients you'll follow up, and be sure you do, right? And so how often do you follow up with exercise counseling? So 33% said some of the time, 23% said most, and 14% said all of the time. So are you charting that when you follow up? Are you doing that? Is that what you do? Do you write it in the chart? You do. You just write it in the note, or do you have a form, special form for it? Just write it in the note? Okay, so we're almost done. So keep it simple, right? This is what if you add variety to it, it's just going to overwhelm people, right? One thing at a time, one step at a time. Realistic, practical. You know, if they're going to say they're going to start walking home from work or part of it, then they can't have very heavy bags with shoes that are really uncomfortable. So you just got to kind of brainstorm and make sure everything's in its right place and everything's ready to go. Prepare for high-risk situations, so bad weather, good weather, holidays, work schedule. You know, it's too nice, I'm going to go to the movies instead of exercise, right? And I've heard that kind of thing. So we want to prepare. In our program, the thing we do really well is we prepare people for all their high-risk situations, because if you don't do that, if they're susceptible, you know, we could sort of think of inactivity as almost an addiction, and they'll default to anything else but. So if you can prepare them ahead of time for all the high-risk situations, if you can spend a few minutes doing that, I think you'll be well served. Okay, so last couple slides. So I like to measure aerobic fitness in the field, so this is just how much less out of breath are you? It's really simple. Do you notice that you have more energy, less out of breath? Do you recover faster? Are you lifting packages easier? Some people have higher energy levels. Not everybody, but many. Sleep is equivocal. Some people sleep better, some don't. I like pedometers. This one I like in particular because you can wear it in your pocket and it's very accurate. The first few weeks that I give pedometer, I just have people monitor how many steps they're taking and then work from there. So not an assignment at the beginning, and then you can increase by, it takes 5 minutes to walk 500 steps. Okay, so the goal is 10,000 steps. That's the guideline. That comes from old data from Japanese blood pressure studies, actually, where they found that Japanese men who walked 10,000 steps a day had lower blood pressure. So that's the one we shoot for, but I don't talk about that too much in the process of getting people to move more. I just want them to move more. And they'll start to do the work. They go, oh, how can I get a few more steps? So I think it's very helpful. Some people report they feel better. Sometimes aches and pains go away if it's not something mechanically wrong or structurally wrong. And then these are things you can measure in the office. Circumferences change pretty quickly. In the first few weeks, somebody starts to walk. Their slacks may fit looser. They may not have lost significant weight, but they're tighter. Glucose, glycohemoglobin, blood pressure will, depending, change somewhat. And lipids, triglycerides may change. Cholesterol doesn't always change with exercise. HDL doesn't always go up, so you have to be careful with the lipids and not put too much emphasis on that. But these are objective things for measuring. Okay, so here are your barriers to exercise. 9 of you wrote that you have no barriers. 9 of you wrote you have no time. Ha, ha, ha. So what do you say to a patient who says, I have no time? Make time. Yeah, you could take the hard-ass approach. You'll get time back, right? Although you get that time back, you spend all your time exercising. You know that Young joke, I lived longer, but I spent all that time exercising, right? That's right. That's right. Yeah, I think so. And importantly, and I showed you at the beginning, if you can incorporate this into your daily activities, right? Are you really waiting for the bus? Time it. How long are you waiting for the bus? Seriously, just time it. And what you can do is just start walking and look over your shoulder. If you don't see the bus, just keep walking. I give you permission. When you see the bus, you can go get on the bus. But I'm guaranteeing you that some percent of the time, you're going to reach your destination. You ever see anybody run to catch the bus? And then the bus, and then the guy pulls away, the bus driver, and then you're banging on the door, let me in, let me in. It's like the world's on fire. You gotta remember that movie with Dustin Hoffman at the end, he's banging on the, right? You ever see this? I mean, people are like mad. There's madness, right? You're running to catch the bus that's going to take you a few blocks. Like, whatever. So you can incorporate it into the day. Like, start there, right? Just tell me one time during your day where you could move a little bit more than you do now. Just one. Will you commit to that? And get them to sign on that dotted line. Just that. Just that. And they'll be disarmed by it because they're expecting you to do what? Say, you got to do a lot. Right? Go to the gym. That's what they're expecting you to say. What if you take a different approach and disarm them? I do that really well. Everybody thinks I'm going to tell them to do a lot, and I never tell them that, ever. And that's more effective. Let's see. Something else I'd rather do? Well, tough. I mean, do I have to wrap it up? Okay, so let me just show you this thing. Let me show you this. I asked the patients the other day, I'm giving this talk today, and I said, what do you want me to tell the doctors and the others? So here's what they said. Start with physical activity and not exercise. Consider my age and health. Meet my needs. So it's not what you want, it's what they want, right? Tell me that every step counts. Tell me to start small. Don't call it exercise. It burns fat. The first step is most important, and that is really true, right? But in the big picture and the small picture, if you can just make that change, right? So this person had very poor experience. Be upbeat, not admonishing. Don't talk down to me. Don't be condescending, patronizing, and judgmental. Don't try to motivate me by telling me you're killing yourself by being sedentary. And have some empathy. These are real comments from real people. Okay, I'm going to finish with this. So physical activity is a vital sign, and follow-up is critical, right? And if you don't do any of that, probably nothing's going to happen. And so I leave you with these last 2 slides. So this was an email with permission. He said I could show this to you. Hi, Rich. I can walk stairs so much better, and I even found myself running for the bus yesterday, something I hadn't done in ages. Workouts like the one I had tonight make me feel like I can do anything. I burned 561 calories on the elliptical when I could have very easily watched some TV and then went to sleep. I am very proud and happy in this moment. So, you know, like, right? Like, isn't that mission accomplished? Like, that's really good, right? And then this was a woman in that study of the nursing home patients who weightlifted, and this is what she had to say. She's 91. It's very beneficial for me. Things that I couldn't do when I came here, I can do now. I didn't think that I was going to live anymore, but I feel different now. So that's, you know, if you can keep that in mind, that that's what you want from, you know, to help them with, then I think that's good work. Okay, I'll leave it there. Sorry I went over, but.
I want to thank all of you because it's been very stimulating weekend, and hope to see many of you next Saturday, and then the next thing will be that conference on dinosaurs, which will be Saturday. It's a beautiful day, go out and take a walk.
Rich, that was a good talk.
Oh, thanks, Oscar.
You know about heart rate variability and power spectrum.
I'm doing a study right
I
now.
know, I-
Yes, I'm using a device. The guy, he's an MIT engineer in Philadelphia, and he and some of his colleagues wrote algorithms for this. It doesn't just use EKG, and I'll send you the information on it. And